Our next lesson is 11.2. This is the quadratic formula. It looks much more intimidating than it is. I've got it written here on the whiteboard so you can see that kind of clearly while we're going through our examples. The unique thing about quadratic formula is this will always work. Like factoring only works for problems that can be factored. There are times where you wouldn't want to use complete the square because the problems would just get too cumbersome with the fractions, and I didn't really show you any like that, but believe me, they're out there. Quadratic formula always works. Even if a problem can be factored, you can use this instead. So that is nice. If you hate factoring, you can actually use quadratic formula on all of it, which is why I made the point in the video that I just shot with completing the square that you want to make sure you're familiar with that because that particular skill will help us graph. And so you don't want to get so familiar with just doing quadratic formula that you don't learn those other methods as well. All right, so our first example looks like this. 5x squared plus 8x equals -3. This one didn't come to us in the proper form. It needs to be equal to 0 for any of these to work except for the square root method, of course. So we're going to move that 3 to the other side and it's going to become positive. Excuse me. And then we're going to plug in just our coefficients. The x isn't going to go with. So this is A, this is B, this is C. It might even help some of you if you write that off to the side. Notice the x's are not coming along. We're just plugging in the numbers. All right, so quadratic formula. We're going to do the opposite of whatever B is. So B starts off positive, it changes to negative, -8, plus or minus, and this next part is all underneath that radical. That radical extends all the way across. So 8 squared minus, it's always 4, times whatever that A is, times C, all over 2A. And now we just have to work out each piece and simplify it until we can't really go any further. So let's do underneath that radical first. So we're just going to have -8 plus or minus the square root of 64 minus 4 times 5 times 3 is 60 all over 10, or -8 plus or minus the square root. 64 take away 60 is 4 over 10. Notice it's all over 10. That's going to play a piece in just a second. The square root of 4 is 2. So this is going to become -8 plus or minus 2 over 10. I would maybe put parentheses around the numerator at this point because we're going to need to split this. And we're going to say, okay, -8 plus 2 divide by 10. And -8 take away 2 divide by 10. And you want to make sure you do that add or subtract piece in the numerator before you divide it by 10. So -8 plus 2 is -6. -6 divided by 10 reduces down to -3/5. -8 subtract 2 more is -10, and -10 divided by 10 is -1. So my two answers, as you can see, I kind of ran out of space. My two answers are -3/5 and -1. So our first example, we were able to work this all the way down. That's not always going to be the case. Let's do it again. Let's do x squared plus 2x plus 5. This one's already equal to 0. My A is going to be 1, B is 2, C is 5. Write it off to the side if you think that's going to be helpful for you. And let's plug it in. Again, we always do the opposite. So B is a positive 2, so we're going to go minus 2 plus or minus the square root of B squared minus 4 times A times C all over 2A. Let's work out the radical. Negative 2 plus or minus the square root of 4 minus 20 over 2. 4 take away 20 is a negative 16. Since we have a negative underneath the radical, we're going to pull that I out. So since I have the space, I'm going to use it right here. Negative 2 plus or minus the square root of 16 is 4, and that negative is going to become an I. So plus or minus 4I over 2. And now we're going to split it. So we have negative 2 plus 4I over 2. And we have negative 2 minus 4I over 2. Remember how we have to write the I values as two separate, or the I terms as two separate pieces. So I need to go back and simplify this just a little bit more. So watch how I'm going to erase that, and I'm going to write this piece over 2 and that piece over 2. Let me move this out of the way real fast. So negative 2 over 2 is negative 1. A positive 4 over 2 is plus 2I. If I do the same thing on this side, and I write it over 2 and over 2, negative 2 over 2 is negative 1, and then 4 over 2 is going to be minus 2I. Your book might even leave them like that, where they still have that plus or minus. Either way is fine. I just wanted to show you how to split it one more time. All right, third example. So we had one where it was a perfect square, one where it was a perfect square, but it was a negative under the square root. There's going to be some where those square roots can't be simplified at all. And there's going to be some where we're going to need to simplify it by circling our pairs, like we learned how to do in chapter 10. All right, example 3. 2x squared minus 2x minus 3. A is 2. B is, this is our first example where B started off to be a negative, and C is negative 3. So we're going to start off with the opposite of B. Since it started negative, it switches to positive. So 2 plus or minus the square root of negative 2 squared minus 4 times 2 times negative 3. Even though, all over 2 times 2. Even though there's a negative that's being squared, a negative times a negative is a positive. So as I start working out this radical, that's going to be a positive 4. 4 times 2 is 8. 8 times 3 is 24, and 2 negatives make that a positive. So plus 24 all over 4. 4 plus 24 is 48, or excuse me, not 48, 28. And we're almost done. However, 28 can be simplified. So I'm going to write it over here, and let's check and see if there's any pairs I can break out of that radical. 28 is 2 and 14. 14 is 2 and 7. So I have a pair of 2's. One guy cancels. That 2 breaks out. That 7 is left underneath the radical. So rewriting just this piece, those pieces are going to stay the same. We're going to have 2 plus or minus 2 radical 7 over 4. Now, because all of these terms are even, you can take out a common factor. Remember, if this was not an even number, let's say that wasn't even there, you can't just slash right there and simplify that. It has to be able to be factored out of both of those. So, what we're going to do next, think GCF. If there is a GCF, you can pull out. Let's pull that out front. So both of these have a 2 in them. 2 goes into it 2 once. 2 goes into 2 once, so plus or minus 1 radical 7 over 4. And only now, because we have a 2 there and a 4 there, and both of those are even, we can cancel there, and that is a 2 in the denominator. So my final answer for this problem is, it's hard to write, just right there, part of my board. Our final answer is 1 plus or minus the square root of 7 over 2. You don't have to split it because there's not an imaginary piece at the end of the radical. All right, I did choose one more for you just to kind of figure the more practice I can give you, the better. So x squared minus 20x plus 100 equals 0. B is negative, so we're going to go positive b plus or minus the square root of negative 20 squared minus 4 times a times c all over 2a, so 2 times 1. So this is positive 20 plus or minus the square root. 20 times 20, or negative 20 times negative 20 is positive 400, minus 4 times 1 times 100 is also 400, all over 2. Since 400 take away 400 is 0, that entire back piece drops off. So you have a plus 0 and a minus 0, which isn't going to change anything. So basically this all condenses down to 20 over 2, which is 10. This could have been factored. If we factor it, we would get x minus 10 times another x minus 10. And so we would get, once again, the same answer twice, but really just the same number. It's actually called, it's got a special expression, and it's called a double root. And it would come into play more in the graphing lesson, but I don't think we have time to go over that piece either. But it just to familiarize yourself with the terminology. If the same number shows up twice, it's known as a double root. So this is the only skill that's in all of section 10.2. So this is it, and thank you for watching.